morning, students. I am N.V. Krishna Rao, Assistant for Science CSC Department. I am handling the compiler design for the 5th semester. Okay. Now we'll discuss the top-down, bottom-up parsing methodologies. And in this one, our first topic start with the top-down parsing methods. Right? We'll discuss the top-down parsing methods. So here, parsing is of two types. One is top-down parsing method, another one is bottom-up parsing method. Here, top-down parsing method is based on the leftmost derivation, and bottom-up parsing is based on the rightmost derivation in reverse. Right? So here, it is a rightmost derivation, but in reverse we will follow that one. Right? So here, the parsers is divided into top-down parsers and bottom-up parsers, right? So top-down and bottom-up. Here in the top-down one, with full backtracking, without backtracking. In without backtracking, there is a recursive descent parsing method and non-recursive descent parsing method, LL1. Right? In the bottom-up parsing methods, there is a operator business parser and LR parsers. These LR parsers are LRGO parser, SLR1, CLR1, LALR1. So these are the different parsing methods. So the syntax analyzer, the parser, is constructed with help of one of these methods. So that parsing methods are divided into two groups: top-down parsers and bottom-up parsing methods. So this top-down is divided into with backtracking, without backtracking. In without backtracking, there is a recursive descent and non-recursive descent L1 parsing method. Then bottom-up parsing methods, they are operator business LR parsers. The LR parsers is LR0, SLR1, CLR1, LALR1. So these are the different methods in the parsers, right? Now we are considering one example, right? Now we'll discuss what is the top down, what is bottom up, right? So here this is the grammar protections that are given. So these are the grammar protection that is given. Now we want to derive this string. So we'll discuss what is top-down parsing method. Right? In the top-down parsing method, so first we are considering the production number 1. We are considering the production number 1. Then we are expanding with the help of the production number 2. Right? So the root S is derived with the help of first production. In that, the A is derived with the help of second production. Then finally, the capital A is derived to its B. So finally, with the production number 3. So our required string is derived with the help of top-down parsing method. Here, next comes to the bottom-up parsing method. Now we'll see bottom-up parsing method. That is our string. Here, in the top-down parsing method, we start with the starting variable and we'll derive the terminals of the string. Right? In the top-down parsing method, the derivation will start from the starting variable, the root, and it is derived to a sequence of the terminals. It is derived to a sequence of the terminals. And bottom-up parsing is starting with the terminals. It starts with the sequence of the terminals of the given string. From that, we'll map the respective terminal to variable. We will replace a terminal with the variable. We are replacing the terminal of the third production with the variable, right? Terminal of the production with the variable. Then using the second production, we are replacing the variable A and BC with the capital A, right? Then we are replacing that with the help of this one. So production number 1, right? With the production number 4 and 1, right? With the production number 4 and 1. D is replaced with B. Then we are using A, D, E, A, A, B, E with the production number 1, right? So A, capital B and capital A will replace into this our root S, right? So here this third and also the fourth, right? A gives B and capital B gives D. If we observe in the top-down parsing method, we are starting with as and we are deriving the terminal symbols of the given string. But in the bottom-up parsing method, we are starting with our terminal symbols, and we are replacing the terminals with the variables according to the productions of the given grammar, and finally we derive the start symbol, right? So that is a reverse of the rightmost derivation. If you observe here, this is the rightmost derivation, right? Rightmost derivation. First B is replaced, then A is replaced, then A is replaced. So finally our given string is we obtain. That is a rightmost derivation. But that we are doing in reverse, that is a bottom-up parsing method. Here, this is the first step, this is the second step, this is the third step, finally fourth step. So doing in reverse of the rightmost derivation is referred as bottom-up parsing methods. Reverse of a rightmost derivation we consider as a bottom-up parsing method. Now, this is the main difference between the top-down parsing method and bottom-up parsing method. In the top-down parsing method, we are using the leftmost derivation, and in the bottom-up parsing method, we are using the reverse of rightmost derivation. So that is the main difference of the top-down parsing method and bottom-up parsing method, right? So rightmost derivation and the rightmost derivation in reverse is a bottom-up parsing method. Next, top-down parsing method. The key problem is that of determining the production to be applied for a non-terminal. A grammar is given and a string is given, string of terminals, and here this top-down parsing method we have to consider is that determining the production to be applied for the non-terminal. So once a non-terminal is chosen, the rest of the process consisting of matching the terminal symbols in the production body with the input string, right? So once we determined the production, which non-terminal we have to replace, then we have to match the terminal symbols with the input string, right? Here, if we consider the bottom-up parsing, first is whenever the terminal is seen direction to be takes place or not. In top-down, we have to select which non-terminal to be replaced. Here, in the bottom-up, the first task, which terminal is to be replaced, right? Then, when to reduce. So, the first we'll see the top-down parsing. It can be viewed as a problem of constructing the parser tree for input string, starting from the root and creating the nodes of the parse tree in pre-order. Depth first search. So, in the top-down parsing method, we use the leftmost derivation and we start deriving from the root and we'll create the nodes and the parse tree in the pre-order, right? Always we replace leftmost non-terminal in expanded, right? In the top-down parsing method. The mainly top-down parsing methods we are divided into with backtracking, without backtracking. Brute force technique are recursive descent parsing methods with backtracking are the example with backtracking. Without backtracking means recursive descent parsing and predictive parsing are non-recursive predictive parsing or LL1 parsing or table derived parsing are the examples for the without backtracking, right? So these are the different methods in the top-down parsing method. Here we have seen what is the top-down parsing method. In the top-down parsing method, we consider the particular non-terminal which is to be derived, that we have to select first, right? Here, brute force technique are recursive descent parsing with backtracking. What it says that always we select the first possible production. If we able to derive our required input string is fine. Otherwise, we consider the second possible alternative production for the same non-terminal for the expansion of the, for deriving of the non-terminal. We'll see. Step 1. From the, we start with the start symbol. S gives CAD, right? The input string is CAD. So, S is the starting variable, CAD we are derived. Next step, A is we are considering as AB, right? So, the first S has only one production, we are taken as it is. But here, for A, what is the first production is AB. So, we are considered the AB. So, in the expansion of the non-terminal, first we consider the first production. If it doesn't matches, here we require the input string CAD. But what is the string we got? CABD. It doesn't match. So then we take the alternative production, right? Here there is a mismatch. Here due to the mismatch, right, we perform the backtracking, right? We select second production. We select alternative production in the expansion of the variable, which resulting to CAD our input. What is backtracking? Our required input is not derived. So whatever the selected production will be removed and once again we go back the same non-terminal alternative production is derived used in the derivation, right? So we have a non-terminal A is to be expanded. The non-terminal A has two productions. First choice, we have taken the first production, but when you consider the first production, it is giving as CAB, right? But which is not the our required string of terminals. Here, so here we are making the change that we are performing the backtracking. So we are going back to the our parent non-terminal. We are going to back to the our parent non-terminal and we select the its alternative production. We select the alternative production so that we able to derive our required string. So here A gives A and our given string. If that second alternative production also not derived our required string, we'll go back to the parent node and we use the third alternative production of the non-terminal, and it goes on till if we able to derive the required string. Otherwise, simply we say the string is not derived by this grammar, right? So the backtracking is that if the selected production is not deriving the our required string, we go back to the parent node and we select alternative productions of the give non-terminal. So that is the backtracking, right? So here, if one derivation of the production fails, the syntax analyzer restores the process using the different tools of the same production, right? Same non-terminal, right? This is the backtracking. This technique may process the input string more than once to determine the right production, right? It involves the undoing the semantic effects like removing the entail from the symbol table, right? So if we select the first production, but we are unable to derive our required string, so we will come back. So we are undoing the semantic effects, right? The order in which the alternatives are tried can affect the language accepted. So if the any non-terminal has four productions, right? We select the first one, mismatch occurs, second one, mismatch occurs, third one, and goes on. If we are able to derive the string is accepted, otherwise the string is not accepted, right? So that is the concept of backtracking. So recursive descent parsing without backtracking. One is top-down parsing method, another one is brute force method, a recursive descent with backtracking, another one recursive descent parsing without backtracking. Here, in this parsing method, we use a set of procedures for each non-terminal, right? Here, this one will consist a set of procedure for each non-terminal. That is a recursive descent parsing method without backtracking. Here, execution begins with the procedure of the starting symbol, and if able to scan the entire input string, it announces a success, otherwise simply as fail. Listen here, this recursive descent parsing method without backtracking will consist a set of procedures for each non-terminal. It consists a set of procedures for each non-terminal, and here always the execution starts with the procedure of the start variable with the procedure of the start variable. The execution begins with the procedure for the start symbol. Right? Here, void main. So here, A is a non-terminal in our production. So we are considering the A method, A procedure. Right? Here, if a production has x1 to xk, so 1 to A, we are calling the, if xi is a non-terminal, call the xi function. If it is a terminal, then we'll check the current input symbol. Otherwise, an error occurs. Now, if the symbols are matches, then advance the input to the next symbol. Here, in these programs, simply if there is a non-terminal, call its respective procedure. If it is a terminal, check it matches to the current input symbol. If matches, then advances the input to the point to the next symbol. Otherwise, simply error. That's all. For every non-terminal, there exists a procedure. That procedure has some production like x1, x2, xk. If that xi is a variable, call its respective function. If it is a terminal, match with the input symbol terminal. If matches, advances the input to the next symbol. Otherwise, simply error occurs. Right? Now, here we want to write a recursive descent parsing program, a transition diagram as an intermediate level for this grammar. How many variables are there? E, E dash, T, T dash, F. There are 5 non-terminals are there. So for this 5 non-terminals, there exist 5 procedures. Right? For example, here for the procedure E, it will call the T function. If it is returns true, then it calls the E dash function. Right? So here, before writing the program for this grammar, we will use a transition diagram for this grammar to develop the program. So the procedure E will call the T function. If returns true, then it will call the E dash. It also returns, then it is given as success. What is the E dash? It checks the terminal T plus sign. If it is true, then check, call the function T and call the E dash. Then epsilon means directly it will be accepted. Then for the T function, F and T dash. Then T dash function, multiplication, Ft dash. If it started with the multiplication, it must be followed by function F, function T dash. Otherwise, it may be skipped by using the epsilon. Then F function. If it is started with the parenthesis, then it must be followed by E function and closing parenthesis. Otherwise, it will check ID. Right? It will check ID. So this is a transition diagrams written for each non-terminal to develop the procedure for each non-terminal. Right? Is it clear? So using these transition diagrams, now we have to write the procedures. Now, if you observe, procedure E, first call the T function. If it is returns true, then call the E dash. Then T function, call F function, returns true, then call the T dash function. Then F function, if the input matches with the plus sign, then we will perform the advanced function, then call the t function and e dash function, similar to according to our context free grammar predictions. If it matches with the multiplication, then we increment to point to the next symbol, then we call the f function and t dash. Then we call the f function and t dash. Right? Then if it is a f function, then if it matches id, then advance. Else if matches with the parentheses, then advances to advance, then call the e function. Then if it is returns true, then it will check it matches with the right parenthesis along. If else, simply it generate the error message. So for each non-terminal, we are writing the respective processes, and our execution will start with the our root function, that is procedure E. So here we can combine these statements by changing them here. So E dash function is updated, and here E function also we are updating in the transition diagram. Then we are modifying the 5 functions with the 3 variables, right? Then simply procedure E, procedure T and procedure F, right? So simply we are combining the some tasks so that we are minimizing the code. So finally we are writing with the 3 functions E, T and F. So this recursive descent parsing without backtracking, it will consist a functions or procedure for the non-terminals. Simply it follows its respective productions and it will call these respective functions. If it is matching with the terminals, then it checks it's a matching true or false, and it advances to point to the next symbol. Then it calls the next procedure to check the input string is accepted or not. Okay. So here we use the transition diagram for the recursive descent parsing, a predictive parsing, and also for the lexical analyzer. So here we are using the transition diagram for each non-terminal, but in the lexical analyzer for the entire language construct. So that is the difference between these parsing methods and previous lexical analyzer. The labels of H was terminals and non-terminals. So here in this transition diagrams, the labels are terminals and non-terminals. But in lexical analyzer, the labels of edges are only terminals. That is a difference of using the transition diagrams between the parsing methods and lexical analysis. Right? So here some disadvantages. Cannot access the leftmost sentential form. It cannot access the stack containing recursive calls. Writing the procedure for left recursive grammar is crucial. It's difficult. Cannot write recursive descent parser for all types of context-free grammars. It is difficult to automate. So these are the disadvantages with the recursive descent parsing without backtracking. And one more thing, if it has the left recursion, it must be eliminated. So to apply the top-down parsing method, if there is any left recursion is there, it must be eliminated. If the left recursion exists, it goes to infinity. For example, here S is SAD, A gives AB slash T. Here first we select the first production. If mismatch occurs, then we select the second production. But every time due to the left recursion, the mismatch doesn't occur. So we going on applying the first production itself, which results to the infinite loop. So the drawback is, if there is a left recursion, it must be eliminated. That if any left recursion is there in the context tree gamma, it must be eliminated. Otherwise, it goes to infinity. Here, in this method, in the top-down parsing method, we first select the first production, right? First production, then first production. If mismatch occurs, then only with the second select the second production. But it does not result in the mismatch. So we keep on going on selecting the first one. So it gives the infinite loop. So it goes on infinite and it never ends. So to apply this top-down parsing method, the another disadvantage, the left recursions, we must eliminate the left recursion to use this top-down parsing method more efficiently. So in today class, we discuss what is the top-down parsing method, what is the bottom-up parsing method, and the first top-down parsing method, brute force method, recursive descent without backtracking methods. So in the next class, we'll continue with the other concepts. Right? For today, I'm closing this session.
Like, share and subscribe. Hit the bell icon for more updates.